want to stress and make sure that we're all on the same page when it comes to calibrations and anything that we're doing with our data, because quality control, standardization is important for quality control. And that's one of the points that I'd like to stress during the presentation. So when we talk about calibrating an analyzer or sampler, what are we talking about? We're talking about aligning or checking the true output of an analyzer or sampler to a true standard. And we say true standard, we're talking about a NIST standard, standard reference photometer, a transfer standard that's been certified through a standards lab. And Jerry Freeman's going to be talking after me, give a presentation about our standards lab. So we're doing these calibrations to ensure the quality of data across our monitoring network. I talked about how important that is, and we're required to do it as part of a CFR. So the two types of calibrations, we have as-is calibration and we have a final calibration. So typically an as-is is performed when you first arrive at the site, and it's done to assess the initial accuracy of the instrument. And not only that, it also verifies the accuracy of recently generated data. So it verifies all the data back to your last station check or your last calibration that was performed. And lastly, it can be performed to determine if your analyzer or sampler needs further maintenance. The other type of calibration is the final calibration, and that's performed after an adjustment or maintenance has been done to your analyzer. So after you've aligned your sampler or analyzer to a true standard, you're going to do what we call final calibration, where you go back through your calibration points and verify the adjustments that you made. So when should you be doing your calibrations? So to ensure the quality of data across our state and our monitoring network, you want to make sure you're calibrating your analyzers when you initially install them in the field, following physical relocation if you've moved the analyzer, after any major maintenance or repair, if it's drifted outside your acceptable quality control limits, or biannually or every 6 months. And I realize this is not always possible, but if you can, it's always helpful to bracket your calibrations in the spring and the fall, so they bracket high ozone season, the beginning and end. So how should we perform these the calibrations? So like I said, we're trying to, about this whole training, we're trying to make sure we're doing things standardized. So they should be done in a consistent manner across all of our stations in our network in a similar fashion. And they should be done in accordance with CARB, PQAO, SOPs, or instrument manual. And we talked, Darcy and Nathan talked earlier about our CARB-approved SOPs. So we want to make sure, or PQAO-approved SOPs. So we want to make sure we're doing our calibrations in the manner mentioned in those documents. And also, they should be performed by someone other than the station operator. This was a discussion point that came up at our training last week down at South Coast, is if it should be a different person than the station operator doing the calibrations. We want the calibrations to be as independent as possible. So as an operator calibrating your own site, that's almost like yourself grading your own midterm or something like that. So we want it to be as independent as process as possible. So as for multi-point calibrations, so our instruments are challenged at a minimum of 4 points, including a pre and post zero check. So we're talking about like 6 calibration points for gaseous calibrations. Our high points are typically around 80% of full range of the instrument. And a low point should be done, should meet the requirements of 40 CFR Part 58, Appendix A, Section 3.2, which is 0.1 to 0.10 ppm. So therefore, to meet those typical criteria for our ozone calibrations, the points that we use, we have a pre and post 0, and then we have 320, 160, 70, and 50 parts per billion. So unfortunately, the coloring here is a little messed up. It would be hard to see. But one of the things that Matthew Plate talked about in his presentation was the importance of, for quality control charts. And this is an example of the quality control charts that the Air Resources Board we use. So each night we run a precision and a span check on our ozone analyzers, and the results are displayed here in the graph. You can see we have our QC limits there and where plotted the percent from true came in. So let's say you were you just came back from long weekend, Martin Luther King holiday, and your control chart looks like that. What's the first thing you're going to do? Scream. Yeah. Document, yeah. Right, Phil? So we got scream and we have document. Check the machine. So let's say you go out there and you see, check the flow, everything's looking good. You got no faults come up on the analyzer. Then what are you going to do? Run a manual cal? Okay. Leak check? Okay.
Speaking from experience, I would say make sure you hook the probe line back up to the end line.
Yes, that'll do it. That'll get your control chart looking like that. Yeah. Yeah. All very, very good responses here. So let's say everything on the analyzer looks good. All those checks come out. Maybe just due to the analyzer drifting, and we need calibration. So we perform our calibration, and after we do our calibration, our values go back, and our control charts are looking good. So just a couple of notes there, just about you want to make sure that you're doing as-is calibrations before you do any kind of adjustments to your analyzer. So yes, sure.
Struggled with this, I guess, quite a while. Okay, so the as-is, I'm not pushing any buttons. I'm not doing this precision check. Would you call it that?
So no, so that a precision check would be a specific point that you're
Okay, if I did a
like
4-point precision check, is that the same as your as-is calibration? Yeah, it's the as-is.
So not quite. So the as-is would be you're arriving at your site. You're going to check your analyzer at like, for example, the 6 points I mentioned, and that's going to give you a percent difference from your true, and that would be an as-is check. So you're checking the analyzer as is its current state.
And then the final is if I make adjustments or if I need to push a button and say, no, that's 320, not 310.
Correct.
That's what you're going to call a final.
Yes. So you make that adjustment, and then you run through those points again to verify the changes that you made, and that would be your final. So when we talk about adjusting, doing a calibration and adjusting our analyzer, we're talking about adjusting the slope and the intercept of the analyzer to true standard. So we're going to do this if our as-is comes in at plus or minus 3% overall, or greater than 3 ppb for the low point. So for ozone, our low point is 50 parts per billion. So if our analyzer came in at 46 parts per billion, then we're going to want to do our adjustment. So does anyone use calibration graphs for when they're doing their calibrations? No one? All right, well, I'm going to show you one anyway. Couple of people. So here's a graph for as is. You can see the bottom left. It was done by my good friend Calibrator. And so on the bottom axis there, we have our true ozone concentration, and then our instrument response with our 4 points and a regression line through there. So we see this particular analyzer is not looking too good. Our regression, the slope of our regression line is only 0.86. So that's for the as is, and then once a final has been conducted, we see the change in our graph there. Looks a lot better with the regression line slope of 0.99. So we did the adjustment, like I said, then we're going to go through and do our final calibration. So the final calibration, we're going to run through those calibration points again to verify the adjustment that we made. And then an important point that I want to stress is to make sure to keep a record of your instrument slope and intercept, both before and after you do any kind of adjustment. So has anyone out here run internal zero span IZS ozone? Good amount, okay. So for the IZS units, after you perform a calibration, typically you're going to perform an O3 Gen Cal, which is an internal calibration of the unit. And what it does is aligns the slope and intercept of the photometer to the slope and intercept of the O3 generator for when it generates the ozone for your checks. And you should be performing those following the change or rebuild of a sample pump, after a major adjustment of the flow rate, if you replace the lamp, or after conducting your final calibration. So here's another picture of a control chart. I apologize, it's a little hard to see. So for our sites that are run with internal zero span, what we typically do is after we performed our O3 Gen Cal, we take the average of the next 3 times that sequence is run, and that becomes our new expected values for our zero precision and span checks that we use for QC. So you can see here, the analyzer went through O3 Gen Cal was performed, and then with our new expected values, how close it is to true. So as Phil said, if it wasn't documented, it didn't happen. So we want to make sure we're documenting these calibrations with calibration reports. So does anyone outside ARB use the ARB calibration forms? Everyone uses their own. Okay, so regardless of whether you're using ARBs or your own, there are a few things you want to make sure to have documented on your calibration report for every calibration. So I'll run through some of these. Station names, obvious. One important thing is a property number or serial number of that analyzer. You want to make sure we have a paper trail of the maintenance of the calibrations that that analyzer has gone through. We want to make sure to have the information about your transfer standard, the piece of equipment you're using to calibrate. It's one of the things that our QA team asks for when they go to audit your site. So it's important to have that information on your calibration sheet, have it handy. Like I said, it's important to note your slope and offset of your analyzer both before and after you perform your calibration. And then, of course, your calibration points with your results from your analyzer and your transfer standard, and that will give you your percent deviation. And then, per our last TSA, they recommended that we house our calibration reports both electronically on a server. We do that with PDF files. We scan them. And then also have a copy at our monitoring station as well. So I got another joke for you. So why do chemists like nitrates so much? They're cheaper than day rates. Tough crowd. Okay, so transitioning over to from our ozone, our multi-point calibrations over to continuous samplers. So when we're calibrating our continuous samplers, there's, most of us are using our calibrating BAMs. A calibration of a BAM sampler includes your outside temperature sensor, the internal pressure sensor, your flow controller with a leak check, and just like when you're calibrating your gaseous, you want to use a certified standard. We use, and I know a lot of people use the BGI Delta Cals for that. So when it comes to making adjustments of one of these samplers, if your temperature is plus or minus 2 degrees Celsius from true, your pressure is greater than 10 from true, or your flow is greater or less than 2%. And also, when you perform your leak check, if it doesn't drop, the flow rate doesn't drop below 0.5 liters per minute, typically tells you further troubleshooting is needed. And it's also important to note that when you're doing these calibrations with your Delta Cal to make sure that it's acclimated to the temperature of where you're performing that calibration. Yes?
It doesn't drop below 5, or it doesn't hold below 5. I thought it was 1 liter per minute was a cutoff point.
Well, typically, if your sampler is clean and free of leaks, it'll typically drop below that and hold. If it's bouncing around above and below 0.5, typically it means there's something needs to be cleaned out or there might be a leak.
Okay, so what's the standard? It's 0.5 if you get more than 0.5?
Yeah, our SOP says 0.5. Yeah.
I think it's at a calibration. That's not just, if you're doing your twice monthly check
Yes.
and it's below 1, that's still okay. But so if you come to do calibration, you see it's 5 or more, then you must take action, right?
Right. But it can be it can let you know further if it's if you're still around 1 or 0.9, can be something to tell you that I think I need to clean, check the sharp cut, maybe do some cleaning. Yeah.
There's also the new tape that we're getting, the flat box, the tape that it doesn't seem to shed on the gate anymore, but that has higher leak values than the old tape used to.
Okay.
I noticed 0.4 is about normal.
Really? Okay.
And so that may be a contributing factor.
Okay. I didn't realize we were using new tape.
We can hold off on comments and questions because we're recording. And I want to bring you guys the microphone, so let them finish and we'll bring those around because I want to capture those questions.
Okay. So just a few things to note. The calibration report, when it comes to our BAM samplers that we want to make sure we are documenting. Like I said, with the multi-point or our ozone analyzers, we want to make sure we're recording our property number of the sampler, our information about our flow standard and temperature standard, if there's any slope and intercept that needs to be applied to that, and then our results for temperature, pressure, and flow, our sampler readings against our standard readings. So just kind of wrap things up. I talked about the types of calibrations, when we should be and how we should be conducting our calibrations, and how to document calibrations. So do I have any questions? Get Don real quick.
On your multi-point calibrations, say for instance, theoretically, you have an instrument that can go 0 to 1,000. What if you know for a fact that most of your data, or let's say all your data, is 0 to 100? Would that influence the points that you choose for your multi-point?
Yeah, typically, you still want to run at least at 80% of full scale. But that's part of the reason why we've made adjustments to the range that we're running a lot of our analyzers. So the range is closer down towards ambient levels. 'Cause I know we were running a lot of our analyzers at 0 to 1,000, and we've dropped that to 0 to 500.
Did everyone hear Scott's question from the beginning? Because that was a good comment. Why don't you make that?
Yeah, recently, I'd say in the last year, we've been getting a new kind of tape, I guess from Met 1. And it's in a thinner box, and the tape is harder. It's more polished, and it doesn't shed like the old tape used to, but the downside is we have higher zeros. At least I've seen that, and I've talked to other people. They've seen that too. And I consistently get about 0.4 for my leak checks, and the gate's clean and everything else. It's just, I think it's a factor in the tape.
Okay.
The old tape would, when I say shed, used to build up like little balls on the gate, and they would then start punching and making holes and stuff. I have never had any kind of that with this new tape. I love it, but the only downside is the flow. The leak check tends to be higher.
Okay.
You said earlier that we need to calibrate whenever we perform any major maintenance. And I was wondering, how do you tell after you've performed a task whether or not it passes that threshold?
So let me make sure I understand you correctly. So you're going out and doing maintenance on an analyzer, and then what was?
How do you know what you did passes the criteria as major maintenance?
What is considered major maintenance?
Yes.
Well, it depends on the analyzer. In our SOP, in the SOP for the specific analyzers, we have what type of maintenance typically would require a calibration. And then when you're verifying after your maintenance has been done, that's why you want to make sure you're using a verified transfer standard that's been certified.
And I would assume if you were in question, it'd probably be a good idea to check it anyway, right?
Right.
Hey, Dustin,
Yeah.
when you guys calibrate, do you calibrate to the back of the instrument or through the probe?
So for ozone-only site, we go through the back of the instrument. And then if the site's running a multi-calibrator, we typically would go through the manifold.
Yeah, I had a question when you talked about the IZS units and after you do the O3 Gen Cal.
Yes.
And then you average your next 3 automated sequences it runs.
Yes.
And then, because we haven't got a place where we report percentage deviation from what the standard was to what the next 3 IZS points were. Because I know typically the IZS, your zeros won't come in the same, and you do have a 1 or 2% difference between your standard and the IZS internal cal, even after you've done the Gen Cal and the lamp adjust and all of that.
Right. So that's why instead of just because of that variation, instead of just using whatever it's set to run at, that's why we take the value of the next 3 days, and the average of that's what becomes our expected values that we're expecting to see on our nightly checks.
Then is your expected value still to fall within that 7%, or do you give leeway to the expected value versus the standard value that you just calibrated with?
We use the expected value as the true value. So we would look at percent from that. Percent difference from that.
Perfect. Dustin will be around with more jokes. He'll be around all evening. Tip him well. So no, he'll be part of for discussions afterward as well. Let's give him a big round of applause.